Welcome back. In the last video, we stopped off at line 30. Question 27 is next, and it talks about lines 47. It has to do with lines 47 through 49. It's around here. So it makes sense to just read the rest of the passage. So we just have lines 31 through 51, and then we're done with the passage. And we know right here is the information that has to do with question number 27. So let's just go ahead and finish up the passage. We believe that the bases will be present almost entirely in their most probable forms. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine and guanine with cytosine. Adenine, for example, can occur on either chain. But when it does, its partner on the other chain must always be thymine. The phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of bases can fit into the structure. It follows that in a long molecule, many different permutations are possible, and it therefore seems likely that the precise sequence of bases is the code which carries the genetical information. If the actual order of the bases on one of the pair of chains were given, one could write down the exact order of bases on the other one because of the specific pairing. Thus, one chain is, as it were, the complement of the other, and it is this feature which suggests how the DNA acid molecule might replicate itself. So 27 asks, the authors used the words exact, specific, and complement in lines 47 through 49. So let's just go ahead and box those. So exact, specific, and complement. In the final paragraph, so the authors used the words exact, specific, and complement in lines 47 through 49 in the final paragraph, and that functions mainly to, so what do these words function to do? So it says let's read it again. If the actual order of the bases on one pair of chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. Thus, one chain is, as it were, the complement of the other. So it says if we could find out the exact order of one of the bases, we can kind of find the complement, like in essence copy it. And it is this feature which suggests how the DNA acid molecule might duplicate itself. So exact, specific, complement, duplicate. So it's asking why do the authors use these, or the authors use these words for what? Kind of to show that the DNA molecule can copy itself. Essentially, we are, again, answering the question in our own words. Notice how I'm not jumping straight to the answer choices. I'm kind of, well, I'm not kind of, I'm actually answering the question on my own. So these words are talking about the exact order of bases, the specific pairing, the complement, and it answers right here. And it is this feature which suggests how the DNA molecule might copy itself. Now let's go to the answer choices like we always do, and instead of picking the right answer, let's eliminate the wrong answers. So A, confirm that the nucleotide sequences are known for most DNA molecules. First of all, it doesn't say that. Second of all, that's not our answer. B, counter the claim. We're not countering any claim. So right off the bat, this is wrong. Always look for, be a detective here. Just figure out every word has to be right. And countering the claim, that's already a red flag. That the sequences of bases long can occur in any order. No. Support the claim that the phosphate sugar backbone, again, I don't see anything about a phosphate sugar backbone being talked about here. So this is already a red flag. Of the author's model is completely regular. Nope. That leaves us with D. Emphasize how one chain of DNA may serve as a template to be copied during DNA replication. Do you see how this is just what is stated here? If the actual order of bases on one pair of chains were given, one could write down the exact order of the bases on the other one. Thus, one chain, as it were, would complement the other. It is this feature which suggests how the DNA molecule might duplicate itself. Emphasize how one chain of DNA may serve as a template to be copied during DNA replication. Again, the right answer is always restated in the passage. So the answer is D. I will see you in the next video where we will finish up passage 3.